Hey, my brave organic kiddos. We're going to start out today talking about our first real category of organic compounds, and we're going to talk about how to name them, and then we'll talk about reactions. And so, essentially, here in Unit 2, we're getting at the real heart of the way organic chemistry works and sort of getting you prepared for that tougher stuff in college. So, we're going to talk about alkanes. What are alkanes? Well, essentially, alkanes are any hydrocarbon. Hydrocarbon meaning that it's just hydrogens and carbons, that everything is saturated. Saturated, of course, means that I have the maximum number of hydrogens. So if I've got 3 carbons linked together, then the maximum number of hydrogens I can have around them is 8 hydrogens. Okay, so how does that compare? Well, if we have something that's unsaturated, as in this case, this would be an alkene. Okay, and you see that the double bond here, what that essentially does is it pulls 2 hydrogens out, and so that system is no longer saturated with hydrogens. It has less hydrogens than it could possibly have. And then that is going to be compared to another type of hydrocarbons we can have, which would be benzene rings, which are aromatic compounds. They're cyclic compounds. Benzene is the simplest one, and then we can obviously add on a bunch of stuff from there. So we're going to start in this unit talking about alkanes and get a good grasp for sort of the general principles of nomenclature and how to name things. That's what we're going to talk about in this video. And then we'll talk about some simple reactions of alkanes, and that's going to be our basis for getting to the more complicated stuff that we'll get to here shortly. So how do we name these things? Well, we're going to learn in this video, we're going to learn specifically how to officially name them according to IUPAC rules. And I'm not going to read the IUPAC rules or anything like that. I'm going to go through a system of rules that goes along with IUPAC rules. And then in another video or in class, we'll talk about how to name them, how to give them common names. Because again, the trick for naming an organic chem or really chemistry as a whole is that there's a systematic way to approach it, which is always the IUPAC rules. And then there's the way we've done it for a couple of hundred years in many cases. And so a lot of times things have trade names or they have common names that get used a lot. And so you really have to be pretty familiar with those in addition to the IUPAC rules. All right, so let's get going. Alkanes, the first 2 rules are really simple. An alkane, any saturated hydrocarbon is going to end with the suffix ane. Okay, and so you've heard some of these before in your life. Propane is a common example. That is a 3-carbon alkane. Butane is another example. Methane. Those are all alkanes. They all end in ane. Okay, and so if it's an acyclic, meaning that it's not in a circle, okay, saturated hydrocarbon, it's going to end in ane. If there are no branches, meaning that it's just like a straight line, or if it curves, that it's all one continuous line, then it's real easy to name them. They just get named by how many carbon atoms do they have. And so this is the way the names go. I would say pause the video, copy these down. You essentially have to memorize these. You just have to know these 10. There's more than this, of course, but these 10 will essentially do everything that we need to do this year with a couple of exceptions, and we'll cross that bridge when we get to it. You'll note that they generally go along with standard prefixes. So pent for 5 and hex for 6 and oct for 8. The difference being, of course, the first 4. Again, those are sort of common parlance ones. And those are, for some kids, the ones that are harder to memorize. Very often propane and butane are the ones that sort of get mixed up a lot. So just commit those to memory, put them on some flashcards, whatever you need to do. Make sure that you've got those 10. Okay, so if they're just in a straight chain, okay, so like if I were going to draw them out, say, if I just drew my carbons out, C, 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 that's a chain of 4 carbons. And I didn't draw the hydrogens in there, obviously, but it's saturated. They're all there. That's a butane. And in fact, we would call that N-butane because it's a normal butane, and it's meaning that it's a straight chain. Every time we do that, every time we add another carbon, we're essentially adding a CH2 to the group. So if it's ethane, okay, it would be C with 3 hydrogens around each one. And then every time we add another one in the middle, since carbon can only form 4 bonds, you're adding another CH2 group in between it. And that makes it what we call a homologous series. Okay, so back to the rules for naming. If there are branches, which is the norm, okay, then you find the longest continuous chain, and this is the trick. This is what gets students to miss this all the time. You're looking for the longest continuous chain of carbon atoms. Anything attached to the main chain, any branches off of the main chain, are called substituents. And what we do is we name the substituents the same way we would name them if they were a chain of their own, except instead of ending in ANE, they end in YL. They're called alkyl substituents. Okay? So we're going to practice some of these. And again, the video, I'm going over the rules. And so in class, obviously, we're going to practice a whole lot of this. So what does this look like? So the main chain, we're also going to number those branches according to the lowest possible number that we can do. So I'm going to give this one as an example of how we would name this in general. So the first thing that we want to do is we want to identify what the longest chain is. And if you look, I could number the longest chain from 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Either way, it's a 5-carbon chain. So what that lets me know immediately is that I know that my root name, and I'll write it up top here, my root name is going to be pentane because the 5-carbon chain. If you're not real sure, where do we get those 5 carbons from? Okay, 5-carbon chain. And again, it wouldn't have mattered if I'd have drawn it up the other way, if I could have drawn that chain up here. Still 5 carbons. So that's the root. Now I have to name the branch. So I've got a branch here. How do I name that? Well, it's a 1-carbon branch, so I know that that is a methyl. Okay, and so I'm going to go ahead and add that right in front of the name. In fact, if it's one branch, that part of the name, there should be no space. It essentially goes together with the other part of the name. So let me scoot that over so there's no confusion there. Okay, so it's methylpentane. The other part that we have to do is I have to tell you where that methyl group is. Where is the branch? Okay, there's 5 carbons here, and if I put this methyl group over here on this carbon, that's different than if I put it on this carbon. They have different chemical properties. They have different chemical names. Okay, those are isomers of each other from what we talked about in Unit 1. So how do I name that? I have to number then my carbons. Our inclination would be to number from left to right because that's sort of just that's the way we read, and so that seems normal. But in organic chem, the way that you number everything is you give it the lowest possible number. So you start from the end of the main chain. My main chain is here. You start from the end of the main chain that gives it the lowest number. So if I'm going to do lowest numbers then, this is going to be carbon, sorry, I lost my pen there for a second. Carbon 1 is going to be here, and then this is going to be carbon 2 and 3 and 4 and so on. I don't really need to worry about those, but this would be carbon 5 down here. If I numbered it the other way, it would be 1, 2, 3, 4, and that would give me a completely different compound. And it would be wrong, okay? Lowest possible number is the only way. We have to have a system to do this so that we can always tell what it is. So in this case, we give it a number, 2, and then a hyphen. And that 2 tells me where is this methyl group. So the methyl group is at 2. The main chain is pentane, and then I have a methyl group on the second carbon, okay, counting from the closest end. So 2-methylpentane would then be the name of this compound. All right, so a couple other rules we'll run through real quick, and then we're going to practice a ton of these in class. So what if you got a big boy like this? Well, again, first thing that you need to do is identify the longest chain. And don't be fooled. A lot of times it just seems easier, well, if I just go by whatever's in a straight line, that's the longest chain. In this case it is, but sometimes it's not. Sometimes the longest chain is to go through and then follow what seems to be one of the branches, okay? So don't be fooled. You're looking for the longest continuous, unbroken, you don't have to backtrack or anything chain, okay? So in this case, my longest chain is right here. We count the carbons on it, 1, 2, 3, 4, 5, 6, 7. So what is that? That is a heptane. I'll try to write a little bit bigger here. Okay. So heptane I know is the base. And in this case I have 2 branches. I've got a branch down here, okay, and I've got a branch here. So remember that the rule is I've got to number these, and I'm going to number them according to what would give me the smallest overall numbers. And when you've got multiple branches, they should essentially add up to the smallest overall number. So 1, 2, 3, and 4. And I don't have to really worry about numbering the other carbons, okay, because I don't have any branches there. If I'd numbered it the other way, though, I'd have 1, 2, 3, 4. That would be the same, but this would be 5. And so when I name these, the total of the two numbers will be higher. So you want to name them in a way that the numbers are the lowest, okay? So that means I have a methyl group at 3, okay, 1 carbon group, methyl, and then an ethyl group, a 2 carbon group at 4. You list them alphabetically, not counting any prefixes. And what does that mean? Well, if I had 2 ethyls, then that would be diethyl. Okay, so you don't count any prefix like that. So it's just whatever the group is, count it alphabetically. So in this case, I have an ethyl group. Ethyl comes before methyl. Ethyl is at 4, okay, and methyl is at 3. So what does that give me for my name then? So that gives me 4 ethyl. I'm sorry for some of the contrast there. And then 3 methyl. And again, sorry for the writing, guys. Remember, I'm writing on a tablet, and I can't actually look at what I'm writing other than looking at the screen, which makes life slightly more difficult for me. Plus, those of you that have been in my class, you know my handwriting's atrocious anyway. So methyl heptane, and again, there should be no space between the last branch and whatever the root name is. All right, I'm going to try to finish, guys. The train is here, so obviously you heard that. We'll hope it doesn't come again. Okay, so again, the branch is 4 ethyl. That's my ethyl. It's on the 4th carbon. 3 methyl. Methyl's on the 3rd carbon. Overall, the longest full chain is 7 carbons, and that makes it a heptane. Okay, so last rule or last real thing for us here for alkanes is that the punctuation matters. The way you write it matters a lot. And I'm a little bit more flexible, obviously, because you're in high school learning this stuff for the first time. When you're taking college chem, they have zero mercy on your organic naming. So I want to make sure that you learn it the right way, and we'll try to practice that, and I'll try to help you out whenever that is possible. So the main part of the name, the parent name, in other words, the heptane from that last group, and the first branch that goes with it is all one word. Okay, so it's not methyl heptane, it's methyl heptane altogether. All right. Any numbers that you write together, so like if you had a dimethyl or a diethyl and they were at different carbons, and so there was one at 2 and one at 3, then you would write that as 2, 3 methyl. Okay, so you got to separate the numbers with commas. There's a hyphen to separate letters from numbers, always, okay? And then as we said, there's no space between the last substituent and the parent name, okay? And again, we're going to practice a bunch of this, and this is one of those things where practice really does make perfect, and working 20 or 30 of these, we should get pretty good at it, and you'll understand it a lot better that way. Real quick, a lot of times in alkanes, obviously we said it's hydrocarbons, but there are what we call halocarbon derivatives of hydrocarbons or halogen substituents. And so sometimes your branch, instead of being a halogen, or instead of being an alkane or an alkyl group, is going to be a halogen. And it's really easy to name those as well. All that you have to do is that you're going to add in the name of that element, take off the INE at the end of the halogen, and add an O. And so, for instance, this molecule, what we do is find the longest chain, 4 carbons, okay, number it 1, 2, because we want to get the closest end of the branches, and so it's going to be a butane. So let's go ahead and write the root word of the name, so butane, and then it's chloro at 2 and methyl at 2, so chloro comes first because alphabetically, so 2 chloro, again, sorry for the writing, that's why you're listening, 2, that's not an equal sign, that's a dash, methyl butane. Okay? And so we're gonna work on the halogens at the same time we're working on the alkanes. They're pretty easy to add in as well. Sorry for the length of the video, guys. This is like our introductory how to name in organic chem. So this video is going to be a little bit longer. The good news is as we go throughout the year, it will be easier because you know the base rules. Find the longest chain, number according to where the branches are closest to the end, all of those things. We won't have to go over that stuff again. We'll just be going over things that are endemic to each functional group. All right? Thanks a lot, guys.